Okay, so question 3 for chapter 3 says a projectile is fired at time t equals 0 from point 0 at the edge of a cliff with initial velocity components of v0x equals 50 meters per second and v0y equals 200 meters per second. The projectile rises and falls into the sea at point P. The time of flight of the projectile is 50 seconds. It then says in figure 3.2e, the y-coordinate of the projectile when it is in the x-coordinate is 1,000 meters. Is closest to. So in this case, they want us to find the y-coordinates. So we know that the breakdown is thrown with a velocity v is equal vy bx plus by, where vx is given. It's 50 meters per second, and Vy is another given, 200 meters per second. Now, we also know that the horizontal displacement x is equal 1,000 meters. Now, when it is the time taken, which is delta t, and delta t, we're going to find it with this equation. When we do that, we go ahead and we put x over vx, which is 1,000 meters over 50 meters per second, and we get 205. Which is 20, no, not 205, I'm sorry, is 20 seconds. So the vertical displacement, which is what we want to know, we have this equation. Now we plug it into we plug in the values into the equation. We're going to have this right here, which is 200 times 20 minus 1/2, 9.8 times 20 squared. And once we simplify all that, we go ahead and get our answer is y equals 2,040 meters. And that should be all for this problem.